Hello friends, once again welcome back to my channel. Today we are going to check what kinds of quality needed for engineers. You know what's the difference? Who is the best engineer and who is a great engineer? Best engineer have a quality of technical knowledge, but great engineer also has a quality of social and emotional intelligence. So let's move on to today's topic. Take a look on what's the esteemed quality that's make engineers top of the world. List out it. First, natural curiosity. If you're a good in curious minded person, then that's help you to perform very well in engineering too. May that make you top of the world. Another one is logical thinking and reasoning, because how to problem arise, how to solve it, how to fix it, this is very important for engineers. Another one is communication skills. Communication skills also very important, because when faced engine like as a managing level, project manager or sales manager, even designer, even sales engineer, you have the quality of communication. If you are best in communication skills, may that help you to go top of the world. Then what's next? Next is a very important things. That is attention to detail. Because it's very important. Attention is very important in engineering. Because you are always playing with the problems. Even a silly mistake, then that may wash out from your career, your job. Even silly mistake that make a big problem, that cause a big problem in your career, in your career life, in your professional life. So be good attention, put good attention on it. This quality is must needed quality. Another one is a special quality. The quality is creativity and innovation. If you have this quality, that may make you top of the world. Because if you have this quality, don't waste your time. If you are working in a space, just come out of it and look around the world. What you can do for next. If you want a job, just don't think I want to work in Google, I want to work in Android, I want to work in Twitter. Don't think like that. Think apart from that. What you can do. Google already found it. So what you can do more than Google. So let's think about it and work out with it and make it. You can achieve it if you have this quality. So then if you want to do it. So that's make you go to top of the world. Then another one is what is the another? Another one is team player. If you working solo and working team, I think working as a team make you more helpful for you. Because even you working as solo, that's more time consuming. So why are you wasting your time? Make a team and do your work. So teamwork is very important for engineers. So if you are a good player, then that make you top of the world. Another one is, what's next? Math skills is very important. Okay, math skills help you not only your university exam, but it also help your entire career you help. Because engineering is the bunch of maths, bunch of calculation, bunch of problems. So these skills may help you to go top of the world. And another is problem solving skills. It's same like math skills. Problem solving skills also very important, because as an engineer you must face some many problems, so you have to solve it. This skill is very important. So if you are good in problem solving, that may help you to go top of the world. Another one is what's next? Technical knowledge. This is a must wanted quality of engineers, technical knowledge. But if you are excelling in technical knowledge, that may help you to go top of the world. Then another one is constant learning. Don't stop your learn after finishing your course, after finishing your studies. Don't think everything is finished. Just think, no, think finished, I want to learn more. So don't think after finishing B.Tech, don't think I need only a chair and laptop to work it. Just think, I want to learn more. I want to think a bunch of things in my daily life. So work out it. Just put it in your mind. Make it and do it. Then that may help you to go top of the world. So this all quality, I hope this all quality have you everyone. So what's next? If you are going to work a particular firm, particular company, then what you can do? What you can do from there? So there is much of things to know about the particular company. So apart from this all quality, you must have to learn something more about the particular company. I'm talking about HVAC. As an HVAC engineer, especially for HVAC, something you have to know before you are joining a company, how you can perform very well there. So that is I'm going to list out next. So don't go anywhere. Let's watch until finish this video. Okay? If you want to perform as a HVAC engineer, you must have to know problem solving process. So we are going to discuss first problem solving. Every HVAC designer design involves as a first step a problem solving process, usually with the objective of determining the most appropriate types of HVAC systems for a specific application. It is helpful to think of the problem solving process as a series of logical steps, each of which must be performed in order to obtain the best results. Although there are various ways of defining the process, the following sequence has been found useful. I will list out the sequence down. Take a look on that. Define the objectives. The first one is define the objective. What is the end result desired for HVAC? The objective usually is to provide an HVAC system which will control the environment within required parameters at a life cycle cost compatible with the need. Keep in mind that the cost will related to the needs of the process. More precise control of the environment almost always means greater cost. The second point is define the problem. The problem in this illustration is to select the proper HVAC systems and equipments to meet the objectives. The problems must be clearly and completely defined so that the proposed solutions can be shown to solve the problem. Third one is define the alternative solutions. Brainstorming is useful here, like teamwork. There are always several different ways to solve any problems. If remodeling or innovation is involved and one alternative is doing nothing there, evaluate the alternatives. Fourth one, evaluate the alternatives. Each alternative must be evaluated for effectiveness and cost, not that doing nothing always has a cost equal to the opportunity or energy or efficiency lost by not doing something else. Next one is select an
Alternative. Fifth one, select an alternative. Many factors enter into the selection process: effectiveness, cost, availability, practicality, and others. There are intangible factors too, such as an owner's desire for a particular types of equipment. Next one is check. Sixth one is check. Does the selected alternatives really solve the problem? Check it. Next one is implement the selected alternatives. That is seventh one. Design, construct, and operate the system. Next, eighth one is evaluate. Have the problem been solved, the objectives met, and what improvements might be made in the next design? You have to evaluate. Many undertakings fail or are weak in the end result due to failing to satisfy one or more of these problem-solving increments. There is an art in being able to identify the key issue or the critical success factors or the truly beneficial alternative. Sometimes the evaluations will be clouded by constraint of time, budget, or prejudice, or occasionally there is an error in assumption or calculation that goes unchecked. The best defense against disappointment is the presence of good training and good experience in the responsible group.
Apart from that problem solving process, you have to know the codes and regulations of a particular country that you work in. So next is codes and regulations. No HVAC designer should undertake a design task without first having an awareness of and hopefully working familiarity with the various codes and ordinances which govern and regulate building constructions, product design and fabrications, qualifications of engineers in practice, etc. Codes generally are given the force of law on the basis of protecting the public safety and welfare. Penalties may be applied to those who violate the established codes, and the offending installations may be condemned and regarded as unsuitable for use by enforcement authorities. As a young design practitioner, we were advised to curl up with a good code book until we became thoroughly familiar with its precepts. Codes are particularly definitive regarding a building structure's integrity, electrical safety, plumbing, sanitation, fuel-fired equipment and systems, fire prevention, detection and protection, life safety and handicapped accessibility in buildings, energy conservation, indoor air quality, etc. Each of these areas has an impact on the design of HVAC system. Particular codes are sufficiently diverse in their adoption and implementations that it is unwise for this video to list any specifics. The HVAC systems designer should simply know that life is not without constraint, that systems will conform to codes or else a permit to build and use will be denied, and that willful violations of codes by the designer is done only at great personal risk. The recommended practice for every HVAC design assignment is to make an initial review of the locally enforced codes and regulations, to become thoroughly familiar with the applicable paragraphs and to religiously follow the prescribed practices, even though such an approach seems to stifle creativity. Occasionally, code constraints seems to violate or interfere with the objective of a construction. At this time, it is often possible to request a variance from the authority. There is no guarantee of acceptance, but nothing ventured, nothing gained. Good preparation generates hope and understanding and differentiate you from the unending stream of charlatans who seek to sidestep codes and regulations for personal financial gain. Okay guys, before ending this video, I'll give you some advice about value engineering. So take a look on that. Value analysis or value engineering describes a new highly sophisticated analytical process which had its origin in the material shortage of World War II. In an effort to maintain and increase production of war-related products, engineers at General Electric developed an organized method of identifying the principal functions or service to be rendered by a device or system. Then they looked at the current solutions to see whatever it truly met the objective in the simplest and most cost-effective way, or whether there might be an alternative approach that could do the job in a similar, less costly, or more durable way. The results of the value engineering process now permeate our lives, and the techniques are pervasive in business. Consider our improved automobile constructions methods, home appliances, and the likes as an example. Even newer technologies such as those pertaining to television and computer have been improved by quantum leaps by individuals and organizations, challenging the status quo as being inadequate or too costly. Alfonso Dell'Isolo is generally credited as being the man who brought value engineering to the construction industry, which industry by definition includes HVAC systems. Dell'Isolo both wrote the book and led the seminar which established the credibility of the practice of value engineering in architectural and engineering firms and client offices across the land. There is a national professional society called SAVE, Society of American Value Engineers, headquartered in Smyrna, Georgia. The society certifies and supports those who have an interest in and commitment to the principles and practices of the value engineering process. Value engineering in constructions presumes an issue at hand. It can be a broad concern such as a system, or it can be narrow concern such as a device or components. The value engineering process attacks the status quo in 4 phases. Let's look at that. First one is gather information. Clearly and succinctly identify the purposes of the item of concern, then gather information related to performance, compositions, life expectancy, use of resources, cost to construct, the factors which comprise its duty, make graphs, charts, and tables to present the information, identify areas of high cost in fabrications and in operation, understand the item in general and in detail. Next one is develop alternatives. First ask the question, do we even need this service at all? Or are we into it by habit or tradition? If the function is needed, then ask how else could we accomplish the same objective? Could we reasonably reduce our expectations or acceptable reduce the magnitude of our effort? Could we eliminate excess materials, make it lighter or smaller? Could we substitute a less expensive assembly? Could we eliminate an elements of assembly labor? Could we standardize a line of multi-size units into just a few components? In this phase, we learn not to criticize, not to evaluate for the crazies spawn the winners. Don't be down on what you are not upon. Be creative and open-minded. Keep a written record of the good ideas. Evaluate the alternatives. Having developed ideas for different ways of doing the same thing, now evaluate the objective and subjective strength and weakness of each alternative. Study performance versus cost both to construct and to operate. Look for the alternative which will work as well or better for the least overall cost. This will often be a different solutions from the original. Note that an analysis effort solely for the purpose of cutting cost is not really value engineering, for the objective of minimal life cycle cost is often compromised. There are enough buildings in this country with fancy finishes and uncomfortable occupants to attest to this assertion. As John Ruskin said many years ago, it's unwise to pay too much, but it's worse to pay too little. When you pay too much, you lose a little money. When you pay too little, you sometimes lose everything. Because the thing you bought was incapable of doing the thing it was bought to do. The common law of business balance prohibits paying a little and getting a lot. It can be done. If you deal with the lowest bidder, it is well to add something for the risk you run. And if you do that, you will have enough to pay for something better. Let's take a look on fourth point, sell the best solution. This ties back into a weakness of many engineers and designers. They have great ideas, but they have a hard time getting these ideas implemented by first understanding the purposes of device or system, then producing good data to understand current performance, and finally developing an alternatives with documented feasibility. The sales effort is greatly supported. Gas-forced air furnaces are an example of an HVAC unit which has been improved over time by value engineering. The purpose of the furnace now as before is to use the chemical energy of a fuel to warm the environment. That's to heat the house, but there is a world of difference between the furnace of the 1930s with the cast iron or heavy metal refractory lined firebox and the 4 feet diameter bonnet, and the high technology furnaces of today. Size is down, capacity is up, weight is down, relative cost is down, fuel combustion efficiency is up, and reliability is debatably up. Then variable speed drives for pumps and fans are devices which have been improved to the point of common applications. The operating cost advantages of reduced speed to match the load have been known and used in industry for a long time, but technology has taken its time to develop reliable low-cost variable speed controllers for commercial motors, such as variable frequency drive now used in HVAC applications.